So how can we call the most desirable best fit line a least squares regression line? Well, I'm glad you asked. We can assess how good a best fit line is by its residuals. Some residuals are positive, some are negative, and much like squaring deviations to get rid of negatives and adding them up along the way to calculating the variance, squaring residuals is the approach to get rid of negatives and adding them up when assessing lines of best fit. The line that fits the data the best prevents having residuals that are too big, observed points too far from the predicted y values. Hence, the line with the least sum of squares or residuals is the best of all possible lines and is therefore called the least squares regression line. Thankfully, we do not have to guess how to find the least squares regression line equation. Soon we're going to look at simple formulas to calculate both the slope and y-intercept, and we will learn how to let the calculator find the LSR line for us. Suppose you were given 4 points on a scatter plot along with the least squares regression line for the 4 points. Use the diagram to explain what it means to be the least squares regression line. When one answers an FRQ, a free response question for AP, it's best to plan the response. Be precise, concise, and yet thorough. If you immediately start to write a full response, you may ramble or forget a key component. Your goal: correctly and fully respond to the questions, supporting your answers with good math and solid understanding. In this response, we would want to consider and explain why it would be the least squares regression line, remembering it involves squaring the residuals. We would need to confirm our understanding of a residual and also share why other lines would not fit the data as well, providing contrast. Here'd be one example of a complete response. If we take the vertical distances from each point to the line, these would be the residuals. They are the difference between the observed y and predicted y for each point. Since we are told this is the least squares regression line, then squaring these residuals and adding them up would give us a smaller sum of the squares of the residuals than any other line we could fit through the data.